Okay, good afternoon, and we're going to do some questions on the light topic, especially questions from lenses, concave lens and convex lens. And these questions in this paper, okay. This question is this question, okay. And I thought this Saturday class, I thought this question 1 to 4, but I repeat again because Monday, Tuesday I did not teach the questions, so I repeat the questions for Saturday class also. Okay, this question 1 to question number 21. Question 1 to 21. We're going to do the questions. We're going to do all the questions. Okay. Especially question number 1. If an object is placed 20 cm from the convex lens, the image formed is of the same size as the object. If the object is now placed 8 cm in front of the lens, state the characteristic of the image. Characteristic of the image. Okay. So they tell this. Okay. They put object. They put object before the lens. So 20 cm before the lens. Because of that, the image you get same size. Is a convex lens. So when you get image same convex lens, convex lens 5 diagrams. So out of 5 diagrams, which diagram says image is the same size of the object? It's a calculation question. Image is the same size of the object lah. Image is the same size object. Okay. We got this one U. Okay. For example, this one is lens. This lens. Okay. This one is 20 cm. They place the object 20 cm before the lens. 20 cm before the lens, and they got image the same size. Image also same size. When you get image same size, which category? Out of the 5 category I gave you. Okay, U less than F, U equals to F, U between F and 2F, U equals to 2F, U more than 2F. 5 diagram I gave convex lens. So which diagram shows image is same size as object? This diagram. U sama dengan 2F. U object distance equals to 2F. What is the object distance? What is the object distance? 20 cm. Object U is object distance. 20 cm equals to 2F. So F equals to what? 10 cm. The F equals to 10 cm. So they gave this first information, image same size object. The first information in order to find the focal length. The focal length. So the focal length is 10 cm. The focal length is 10 cm. So now the object is less than focal length. The place object 8 cm. So they place object now. Now the place object distance 8 cm. Object distance now 8 cm. 8 cm is between U must be less than F. U must be 8 cm. The focal length is 10 cm. The focal length is found from the same image just now. The lens is same. Length is the same lens. Two situations. The first situation, the object 20 cm from the lens. Second situation, the object 8 cm from the lens. So the lens, same focal length. Focal length must be same. Two situations. Object distance 20 cm, object distance 8 cm. But the focal length is same. To find the focal length, that's how you found this one. U sometimes do F. So 20 cm equals to F. So F equals to 10 cm. F equals to 10 cm. F equals to 10 cm. Okay, F equals to 10 cm. So the focal length is 10 cm. The object is 8 cm now. Now the place object less than focal length. 8 cm. So object less than focal length. So this is category number 1 lah. Category number 1. U less than F. U less than F. So what's the category of the category 1? What are the characteristics of the image? The image virtual, enlarged, magnified, and upright lah. So answer C. Answer C. Question number 2. The focal length of convex lens is 15 cm. The focal length is convex lens 15 cm. An object is placed 20 cm in front of the lens. An object is placed 25 cm in front of the lens. In front of the lens, the image form is okay dear. The focal length. Okay, the focal length. Now the lens, different lens lah. Now different lens. The focal length is 15 cm. The focal length is 15 cm. The focal length is 15 cm. An image is placed 25 cm in front of the lens. An object is placed 25 cm from the lens. The image form is the object is 25 cm. Object distance is 25 cm. U must be 25 cm. So U must be between F and 2F. Because F is 15 cm. 2F is 30 cm. F is 15 cm. 2F must be 30 cm. So the object distance is 25 cm. So object distance is 25 cm. So it's category number 3. Category number 3. So the object distance between F and 2F. Category number 3. So object is more than F but less than 2F lah. More than F plus 2F. Object distance more than F but less than 2F. So the image must be real. The image must be real, enlarged, magnified, and inverted. So the image somewhere like this. Image can somewhere like this. Image inverted. Image will be this one. The image will be inverted. The image will be enlarged, magnified, and image will be real image. Real image. Question number 3. Question number 3. Okay, question number 3. The focal length of the convex lens is 10 cm. The focal length is 10 cm. A pen is placed in front of the lens. The image pen is formed 30 cm behind the lens. This one behind the lens. The image formed 30 cm. The image formed, the V equals to 30 cm. The image formed 30 cm from behind the lens, behind the other side of the lens. Same side. The object and the image same side means virtual image lah. Object this side, image is this side. Okay. Okay, the object is placed here. The object placed here. The object placed here. The object placed here. But the object will be more than F. More than F. Because less than F, the image and the object is same side lah. So the image is, since you got image other side of the lens or behind the lens, the object must be more than F. The object must be placed more than F. This is category 3 onwards. Category 3 onwards. Category 1 and 2, object distance less than F, object distance equals to F. Then one you got image same side object. The image same object. Image and object. Image and object same side. Image and object same side. Then you get image and object same side. U less than F, U equals to F. These two categories. In these two categories, object and image will be same side. So since the image you got behind the lens, the other side of the lens, then the object must be more than F. The object must be more than F. Okay. So the question asking you, calculate the magnification obtained. The magnification, the formula V over U, or size of image or size of object, or height of image or height of object. Okay, height of image or height of object. Okay, but this formula is V or U. This one is an appropriate formula because the size of image or size of object is never given, but they give distance. Okay, the distance of image is given. Distance of image is given. Okay, V equals to 30 cm. The distance of the image is given. Okay, so the formula 1 over U plus 1 over V equals to 1 over F. So 1 over U. So the U, the distance of object, you have to find object distance. You have to find object distance. So you must use the formula 1 over U plus 1 over V equals to 1. Why must plus? Why must plus? Why is not minus? Minus means this two category. 1 over U minus 1 over V equals to 1F. This two category. U less than F, U equals to F. The image gets same side object, so you must use minus. But this one you must use plus, the formula plus. Because the image other side of the lens, or image you got behind the lens. So 1 over U plus 1 over V equals 1F. So 1 over U, V equals to what? 30 cm. The V is 30 cm and F equals to 10 cm, the mentioned earlier. So 1 over U equals to 1 over 30 minus 1 over 10. So 1 over 10 minus 30. This one minus here. So this one times 3. Okay. So times 3. So 1 over U equals to 3 minus 1 over 30. So 1 over U equals to 2 over 30. So U equals to must be. So 1 over U equals to 1 over 30. 2 over 30. 2 over 30. 3 minus 1. So cross multiply, U must be equals to 30 over 2. Cross multiply 30 over 2. Okay. So U equals to 15 cm. So from this you found the 15 cm. The what you call image distance or object distance. So use a formula. M equals to V over U. The image distance we know earlier, 30 cm. Object distance 15 cm. So the magnification image is probably 2. The magnification image must be 2. Okay, magnification of the image must be 2. Okay, and the next question. Concave lenses form images that are virtual only. Virtual only. Concave lens, regardless object distance. I gave only one diagram for concave lens. Convex lens 5 diagram. Concave lens 1 diagram only. Regardless of object distance, concave lens will form the virtual image only. Virtual image only. Question 5. Question 5. Diagram 34 shows a ball, a radius 6 cm, and its image is found by a convex lens. The image distance is 24 cm. Determine the magnification. Okay, the ball means object, like the ball means object, and the image is 18 cm. And okay, the ball is okay, image. Okay, height to the image. Magnification, height of image, height of object. The height of image is 18 cm. The image 18 cm is very blur. So 18 cm. Height of the image is 18 cm. The height of the object is 6 cm. Because height of the object is 6 cm, more 6 cm. So the magnification equals to what? 3. The magnification equals to 3. Okay, and find the object distance. Find the object. Since like this, so this object, this image, because so object is this side, the image is this side. So object and the image the same side can be virtual image, lah. So object this side, the object is ball, and the image this side. So image this side. So it's not same side, lah. Object and the image same side like this. Image same side. That one is a virtual image, like U less than F, U equals to F. So this one will be object and image is other side, other side of the lens, other side of the lens, all behind the lens. Okay, find the object distance. Object distance. So how to find the object distance? Okay, find the object distance. Question number 5. 6. Okay, m equals to v over u. We can use either formula. Height of image or height of object, or image size of image, size of image or size of object, either formula, or m equals v over u. M is since we found 3. Magnification same. Either you use height of image or a height of object, or we use v or u, image distance or object distance. Same magnification for same lens, same ball, same object, same image. So magnification 3. Question 3. The V, the image distance, they give the answer. The image distance 24 cm. And object distance you don't know. So U is must be 3U equals to 24. U equals to 24 divided by 3. 24 divided by 3 is 8 cm. No? 8 cm. Okay, 8 cm. 8 cm. No? Okay, 8 cm. So U must be 8 cm. U will be 8 cm. The object distance will be 8 cm. Okay, question 7. Question 7. What is the focal length of the lens? Focal length of the lens. So the formula 1 over u plus 1 over v equals to 1 over f. 1 over u is equals to 8 cm. And 1 over v must be 24 cm. The v is to give this question 24 cm. The v 24 cm equals to 1 f. So 8 times 3 times 3. 8 times 3 is 8 to 1, 3 plus 1 over 24 equals 1 of f. So 4 over 24 equals 1 of f. Okay. So f equals to what? Cross multiply f equals to 24 over 4. 24 divided by 4 is f equals what? 6 cm. 24 divided by 4 is 6 cm. Okay, 6 cm. So f must be 6 cm. Okay, f must be 6 cm. Question 7. Question 8. Question 8. Now, question 8. We are now doing question 8. Okay, question 8. Question 8. Question 8. If the magnification of the convex lens is 4, if an image is formed a distance of 20 cm behind the lens, find the object distance. Okay, this object here, and image is formed behind the lens. Behind the lens means other side of the lens. So must be real image. Real image. I tell you this one again. The object and the image same side but virtual image. The formula 1 over u minus 1 over v equals 1 f. And what the situation, we get object and image same side. U less than f, u equals f. First two category. So last three category, category 3, category 4, category 5 is image must be formed behind lens, other side of the lens, or image real image. So the formula behind lens, find the object distance. Okay, the image distance. Image is formed at the distance. Okay, the image distance 20 cm. So the image distance m equals to v over u. The magnification is 4. They say magnification is 4, and the image distance is 20 cm. Object distance you don't know lah. Object distance don't know. So cross multiply. U equals to 20 divided by 4. U equals to 5 cm. So the object distance is 5 cm. The object distance is 5 cm. Question 9. Question 9. The magnification of the convex lens is 2. Calculate the distance between the object and the image. If the object distance 8 cm. Calculate the magnification of the convex lens. Magnification of convex lens 2. Calculate the distance between object and image if the object distance is cm. So for this question, object distance Okay, this question. Now, this object distance they give. This question object distance they give. Okay, object distance they give. The u equals to 8 cm. The magnification 2. So the 2 magnification. Question number 9. Question number 9. Question number 9. Question number 9. The magnification 2 and calculate the distance between object and image. So for that you must find the image distance because they are asking distance between object and image. So image distance we don't know, but object distance we know 8 cm. So 2 times 8. So 16 cm V. So the V equals to 16 cm. The V equals to 16 cm. So what is the distance between object and the image? What is distance object and the image? The image distance you found 16 cm, the V. The object distance and the image distance. What is the distance? What is the distance between object and image? So 8 plus 16. So 8 plus 16, 24 cm. Because this one 8 cm from here to center of the lens. 8 cm. And from center of lens image distance 16 cm. So altogether 24 cm. Okay, question 10. Question 10. The question really need my help. Unless you can do the question, that means marvelous. La. You can do the question for 10. Something like a very good, you're good. Question 10. Okay. Focal length or convex lens is 10 cm. The focal length of convex lens. The focal length is 10 cm. Okay, this question you must do a 3-4 categories, 3-4 steps. You must do the question. Focal length is 10 cm, and inverted image is formed. Inverted image must be the object must be like this lah. The object may be more than focal length because inverted image must be other side of the lens. Other side of the lens. U less than f, u equals f, or virtual image. The same side of the image, object and the same object, same side of the image. Object same side of the image you get these two image, object and image the same side. When you got u less than f, u equals f. Okay, object and image same side. But because inverted and upright image, image upright, so invert same size, same side. Object and image same side. This one u less than f, u equals f. This one same side. The image is upright lah. But this one image inverted. Image inverted must be image the other side of the lens. Inverted image or real image must be other side of the lens. Okay, and inverted image formed by given that the size of the image twice the size of object. Size of the image is twice the size of the object. Calculate the distance between the image and object. Okay. Now, M equals to V over U. M equals to V over U. The magnification, given that the size of the image twice the size of object. Size of the image twice the size of the image means, in other words, magnification. So magnification 2 V over U. So 2U equals to V. V must be 2U. V must be 2U. Because object distance we don't know. But they said the size of the image twice the size of object. Okay, so and V equals to 2U lah. Okay, now we use the formula 1 over U plus 1 over V equals to 1 over F. 1 over U, you leave the U. You leave the U lah. U. 1 over U. U. Object distance. V is equals to 2U. V equals to 2U. So 2U equals to 1 F. F equals to 10 cm. F equals to 10 cm. F equals to 10 cm. So times 2. F focal length to 10 cm times 2. So 2 times 2 plus 1, 2 plus 1, 2 plus 1 equals to 2u equals to 1 over 10. 2 times 1 times 2, 2 plus 1. Okay, cross multiply. Okay, 2 plus 3, 30. 30 here we 2u. Cross multiply. 10 times 3, 10 times 3, 30. So u equals to 15 cm. So this formula m equals to v over u. So the 2u equals to v. So 15. U is 15 cm. So what is v? What is v? 2 times u is 15 cm. So v is 30 cm. So v is 30 cm. V 30 cm, u is 15 cm. So the distance between object and image, remember, object and distance. This is a u, 15 cm. This is v equals to 30 cm. So the distance between object and image. Distance between object and image. So 15 cm, 15 cm, 15 cm object distance, 30 cm image distance. So 45 cm. So 15 plus 30. So is equals to 45 cm. 45 cm. So the image distance is 45 cm. Image distance is 45 cm. Object and distance between object and image is 45 cm. Okay. Next question, question 11. I suppose question 11 is tough question. Supposed to be question 11. Okay, question 11 is tough question. Question 10 is quite easy. Question 11. Okay, question 11. Focal length or convex length is 10 cm. Focal length is 10 cm. Focal length is 10 cm. A 4 cm tall object is placed 6 cm in front of the lens. Calculate the height of the image. Calculate the height of the image. Remember that? Let's say focal length is 10 cm. The 4 cm tall object is placed 6 cm in front of the lens. The object is placed u equals to 6 cm. The u equals 6 cm. Okay, the object 4 cm tall object. The 4 cm tall object is placed 6 cm in front of the lens. So this image, what is the image look like? Same side of the image or behind the lens? Image must be formed same side of the lens, because this category u less than f, u less than f, because u is 6 cm and f is 10 cm. F is 10 cm. So the object distance is 6 cm, less than focal length. So the object you get object less than 6 cm or less than object distance is 6 cm or less than what you call object distance is less than focal length. So object you get object will be less than focal length. So the formula we use 1 over u minus 1 over v equals to 1 over f. Minus because image virtual, you get same side image. Image for same side. Image same side. When you get image same side, u less than f or u equals to f. U less than f or u equals f, then you got image same side. Image same side means image upright, and the image, the formula is minus, not plus. Plus means image means other side lens, behind lens. Then 1 over u plus 1 over v equals 1 f. Inverted lens, inverted image. Okay, this image other side lens, the image this side. This one is the plus formula. You got plus formula. This one is the minus formula. So u equals to 1 over 6. 1 over V, 1 over F. F is equals to 10 cm. So this one is 1 over 6 minus 1 over 10, 1 over 10 equals 1 over V. Please bring here 1 over V positive. So this one is times 3 times 3. This one is okay. 6 times 6 times 3, 60. Yeah, 60. 10 times 60. 6, 10. Okay. So 60, making more some 60. So 10 minus 6 over 60 equals 1 over V. So 10 minus 6 equals to 4 over 60 equals 1 over V. Cross multiply, V equals to 60 minus 4 over 4. 60 minus 4, 2, 30, 15. So V equals to 15 cm. So the U equals to 6 cm. The V equals to 15 cm. Okay. U equals 6 cm and V equals 15 cm. U we know 6 cm. And by the formula we found a V. V equals 15 cm. So the magnification equals to V over U. So magnification is V equals 15 divided by 6. Divided by 6. So magnification 2.5. I think so 2.5. 2.5. 6 divided by 2. 12, 3, 2.5. 2.5. Magnification 2.5. This is one formula. The same length, same object, same image we can get from the size of the image or height of the image. So the magnification, the height of the image, it's not a very difficult question to do. So many steps, height of the object. The magnification must be same. The magnification must be same. Because magnification is formed from V to U, or the height of the image or height of the image, same, because same length, same object, same image. So the magnification will be 2.5. Height of the image. The height of the image we don't know. Height of the object is 4 cm. They say 4 cm height of object. 4 cm. So 2.5 times 4 equals to height of the image. So height of the image equals to what? 2.5 times 4 equals what? 10 cm. Okay, the height of the image is to be 10 cm. The height of the image is 10 cm. Question number 12. Question number 12. An object is placed 12 cm in front of the convex lens. An image is formed at the infinity. If the object is placed 8 cm in front of the lens, the image must be what? Okay. An object is placed 12 cm of lens. Okay. This one. The object is placed 12 cm. The object is placed 12 cm. So the image form infinity. When you get infinity image, infinity, U equals to F. When you got U equals to F, the infinity. So the U is 12 cm. F equals to 12 cm. The U equals to 12 cm, F equals to 12 cm. So in other words, the focal length is 12 cm. So you place the object at 12 cm. The place object at 12 cm, object distance at 12 cm, same as equal to the focal length. Focal length also 12 cm. Then only get image in infinity. U equals F. u equals f, the image will be infinity. If the object is placed 8 cm, now the placed object 8 cm. Now the placed object 8 cm. Now the object is 8 cm. Now they place the object 8 cm. Brought forward. Just now the object 12 cm. And object is focal length. Now the object is placed 8 cm. Same length, same focal length. The focal length is 12 cm as object distance for 12 cm. But now they bring the object 8 cm. 8 cm less than focal length. So now the second category, u less than f. F is 12 cm. U is 8 cm. U must be 8 cm. So f is less. U must be 8 cm. So first of all, why they give the information infinity, image infinity? Because to find the focal length. When you got focal length, u equals to f. When u equals to focal length, object distance equals to focal length. Object distance same like the what you call it? Object distance same. Object distance must be same as focal length. Then image infinity. So object distance 12 cm, focal length is 12 cm. So you found the focal length for the list length. So based on the focal length is fixed 12 cm. But object is 8 cm now. Now the place object 8 cm less than focal length. U less than focal length. So the characteristic image, the image form on the same side of the object. Out of the four characteristics, the image D, answer D. The image will be same. The image will form the same side of the object. Question 12, okay? And question 13. 13. The real image of the candle is formed at 60 cm. Okay, question 13. Okay, the image, the object is here, and the image here. Image here is other side of the lens, lah. Okay, image, the real image. The real image is 60 cm. The image real image means inverted image, other side of the lens, lah. The image must be 60 cm, and find the distance between, okay, focal length of the lens. Focal length. The focal length is f. F is 20 cm. The focal length is 20 cm. So find the distance between object and this lens. Object and lens. Find the distance between object and lens, or object distance. In other words, they are asking the u. They are asking u. Question 13. So 1 over u plus 1 over v equals to 1f. Why you plus the formula? Because image equal other side of the lens. Image same side of the lens minus the formula. Minus. So 1 over u. 1 over v. V is 60 cm. 1 over f. F is 20 cm. F is 20 cm. So 1 over u equals to 1 over 20 minus 1 over 60. So times 6. 6. Okay. Sorry, times 3. Times 3. So 1 over u equals to 3 minus 1 over 60. So 1 over u. 1 over u equals to 2 minus 2 over 60. So cross multiply. U equals to 60 over 2. So u must be 30 cm. U must be 30 cm. U must be 30 cm. U means object distance, or distance between object and the lens. Distance from the object to the lens is object distance. Distance between object and the lens is the object distance. Question number 14. Determine the magnification. The magnification is very simple. V over u. V is 60 cm. 60 cm. U just now we form 30 cm. So magnification 2. The magnification 2. Question 15. If the height of the candle is 2.5 cm, what is the height of the image? So same thing, same formula. Same formula. Same formula. The height of the candle, height of the object, the height of the image. Height of the object. Okay, height, the same magnification, same. VOU or height of the object, same. The magnification was 2. Height of the object, image, we don't know height. Height of object, the height of the object is a candle. Height of the object is a candle. Question 15. Height of the object is 2.5 cm. So it's 5 cm. 5 cm is height of the what do you call image. Okay, height of the image is 5 cm. Question 16 we did before. Question 17 answer must be D. Answer must be D. Question 18. Convex lens focal length f can be used as a magnifying lens if the object distance is less than f. Okay, magnifying lens. I told you something, less than f. Object distance less than f, magnifying lens. Magnifying lens is the round lens, the one C1. Okay, I told you that one of the application, the 5 category of lenses, 5 category of convex lens, and I give the application. So application U less than f. Question number 19. If compound microscope, the focal length, objective length is f, the object distance. Compound microscope. The compound microscope we learned what do you call it last week. Microscope, the object distance may be f and 2f, between f and 2f. Question 20. Which of the following combination is not a character of the magnifying lens? Magnifying lens. Answer C. The focal length 15 cm, object distance 20 cm. Object distance more than focal length. Magnifying lens, object distance must be less than focal length. Okay. So question number 19 is B. Question number 20 C. Question 18 is B. Question 25. And an object is placed in front of the convex lens with the power of 10D. If the object distance is 15 cm, state the characteristic image. Okay. The power 10D, the power, you must find the power first. You must find the power equals to 1 F. The power is 10D. 10 equals to 1 F. So F equals to what? 1 over 10 is F equals to what? 0.1 meter. You must get focal length meter. If you use power of lens formula, you get meter. F is 0.1 meter. So F 0.1 meter is 10 cm. Cm. Because the other distance all give the cm. Okay. The object distance, object is placed in front of convex lens with the power of 10D. If the object distance is 15 cm. Now the focal length. The focal length is 10 cm. How do you find the focal length 10 cm? From the power of lens. Okay, the 10 cm, and if the object distance is 15 cm. Now the object distance 15 cm. So the object distance more than f. More than f means image must be this inverted other side of the lens, image on the side. So the state the characteristic image. The image must be answer C. The image is real and the magnification is more than 1. The image is real image, inverted image, or other side of the lens, and the magnification more than 1. Image bigger than 1. Size 1.5 or 2 or 3 or more than 1. So answer is C. So I will see the question. I will teach you that mirror next class, and some questions we do some questions the light topic. Some questions I give you other paper. Then we do another week lah. Okay. Next week, maybe next class we can see. Okay. Thank you very much.